order observable? And how do we map one? Welcome back to Rsjx and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and in this module, we examine higher-order observables and higher-order mapping operators, such as switchmap. Some observables emit primitives, such as numbers or strings. Some observables, such as those returned by an HTTP GET, emit arrays, and some observables emit other observables. In this example, we define a source observable that emits two numeric ID values. Each ID is mapped to an HTTP GET, which returns an observable, so each emitted item emits an observable. Any observable that emits an observable is called a higher-order observable. The original source stream is then called the outer observable, and the observables emitted inside are called inner observables. You'll often see the terms inner and outer observable in the Rsjx documentation when discussing higher-order observables. But there's an issue with this code. We aren't subscribing to the inner observable. To emit the supplier objects from the inner observables, we need to subscribe to those observables. Something like this. The first subscribes to the outer observable, which emits the 3 and 7. The nested subscribes to each inner observable, which emit the associated supplier objects. But this code isn't very nice. How would we subscribe to the inner observables when using an async pipe? And how would we unsubscribe? This technique is not recommended. We should not have nested subscriptions in our code. What do we do instead? That's the purpose of higher-order mapping operators. Higher-order mapping operators transform higher-order observables. In this module, we examine higher-order mapping operators. The specific Rsjx features demonstrated in this module include concat-map, merge-map, and switch-map. Let's get started. Each of our products has a set of supplier IDs. We can use that set of supplier IDs and retrieve each supplier for a product using HTTP GET. Our first thought may be to use the map operator and map each ID to the observable returned from the HTTP GET method. Let's give that a try. We are in VS Code with the APM folder open, this time looking at the supplier service. We want to display the set of suppliers for a particular product. To try things out, let's mock up the observable containing the list of supplier IDs and use those IDs to get each supplier. I'll paste the code and we can talk through it. First, I'll add the missing imports. This one, and this one. Here we use the ofCreation function to mock up an observable containing the list of supplier IDs. We pipe the observable through the map operator to map each ID, calling HTTP GET to return an inner observable that emits the supplier with a defined ID. Then in the constructor, we subscribe. Yeah, I know, there are several issues with that. We've learned techniques that don't require subscriptions, but to try this out, we'll subscribe so we can more readily see the result. And we shouldn't load data from a constructor, but we're just experimenting at this point. Hovering over suppliers with map $, we see that we are working with a higher-order observable because the type is observable of supplier. So it's an observable that emits a supplier. Anytime you see observable of something, you know you're working with a higher-order observable. Now we're ready to try it out. Bring up the browser, open the developer tools, and click Product List. Scrolling up, we see that our logging displays the observable, not the item emitted from the observable. Looking back at the code, here we subscribe to the source outer observable. For each ID, it maps to an inner observable, emits that observable to the output stream, and logs it. Do you see what's missing? To start our inner observables, we need to subscribe. So we nest the inner subscribe inside the outer subscribe and log the result. Here O is short for our inner observable. Looking at the browser and scrolling up, it works. We see each of the suppliers for the specified supplier IDs. But going back to the code, we have nested subscriptions. That's not good. It makes the code more error-prone and complex. It won't work with an async pipe. And how would we unsubscribe? A better choice is to leverage a higher-order mapping operator. Higher-order mapping operators are a family of operators with names that end in map. These operators map each value from a source or outer observable to a new inner observable. They automatically subscribe to and unsubscribe from each inner observable, so we don't have to, and they flatten and emit the resulting values to the output observable. How these operators emit the result is different for each higher-order mapping operator, as we'll see in this module. Examples of higher-order mapping operators include concat-map, merge-map, and switch-map. Let's examine these operators in detail, starting with concat-map. Think of concat-map as higher-order mapping plus concatenation. The concat-map operator transforms each emitted item to a new inner observable as defined by a function we provide. Here we map each emitted item to an observable that emits that item. Concat-map is different from the other higher-order mapping operators in that processing is serial. It waits for each inner observable to complete before processing the next one. The items emitted from each inner observable are concatenated onto the resulting output stream in sequence. In this example, we use the ofCreation function to create an observable containing two strings. This is our source observable. We pipe each string through the concat-map operator to retrieve the data, using the string as an ID. On the marble diagram, the source observable emits two strings, A1 and A2. When A1 is emitted from the source observable, the mapping function executes, which creates the new inner observable. It then subscribes to that observable, and the GET request is issued, using the emitted string as an ID. Concat-map then waits for the response. When the response is returned, the data emitted from the inner observable, an Apple object in this example, is concatenated to the output stream. The inner observable completes. The next emitted string is not processed until after the prior inner observable completes. The mapping function then executes, creating the next new inner observable. It then subscribes to that observable, and the GET request is issued. Concat-map again waits for the response. When the response is returned, the data emitted from this inner observable is concatenated to the output stream. The inner observable completes. And since we've used the ofCreation function, the outer observable completes. As a result, each apple's data is emitted to the output stream in sequence. More formally, concat-map is a transformation operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When an item is emitted from the input stream, it's queued. An item from the input stream is mapped to a new inner observable as specified by a provided function. The function passed to the higher-order mapping operator must return an observable, or a structure that Rsjx knows how to create an observable from, like an array. Concat-map subscribes to this inner observable and waits for it to complete. The inner observable emissions are concatenated to the output stream. When the inner observable completes, then the next item from the input stream queue is processed. Concat-map completes when its outer observable completes. Use concat-map to wait for the prior observable to complete before starting the next one, and to process items in sequence. Consider using concat-map if you have a set of IDs and want to use those IDs to retrieve data in sequence. For example, you have the IDs of the top 10 hottest products, and you want to ensure you retrieve and display that data in order. Or you are updating or deleting data, and you want to ensure each update is complete before starting the next one. Note that when using concat-map to retrieve data for a set of IDs, the user could see a delay in the display as each request response is processed in sequence. Let's try it out in our sample project. In this demo, we try out the concat-map higher order mapping operator. Let's try again to retrieve the set of suppliers for a particular product. We'll still mock up the observable containing the list of supplier IDs, but this time we'll use concat-map. I'll paste the code. First, we add the needed imports. Here, we define an observable of IDs. We pipe each ID through a set of operators. Use tap to log the ID coming in from the source observable. We use concat-map to transform our ID values into new inner observables, and then flatten the result to the output stream. Because we aren't using this observable in our UI, in the constructor we'll subscribe to start the observable. And let's comment out our mapping subscription to minimize the logging. Viewing the application in the browser, scrolling up, we see logging in the console. It logs each of the source observable values and queues them. It processes the first value, creates the inner observable, and subscribes to it, which issues the HTTP GET request. It then waits for the response. When the response is returned, its value is logged to the console, and the observable completes. Then the next outer observable value is processed. The remainder of the logging is down here. If we refresh and watch closely, we can see the delay between each HTTP request. Each inner observable is executed in sequence after the prior inner observable completes. Next, let's look at merge map. Think of merge map as higher order mapping plus merging. Just like the concat map, the merge map operator transforms each emitted item to a new inner observable as defined by a function we provide. Here we map each emitted item to an observable that emits the item. Merge map is different from other higher order mapping operators in that it executes the inner observables in parallel and merges their results. We use the same example, but this time we pipe each string through the merge map operator to retrieve the data. On the marble diagram, the source observable emits two strings. When an item is emitted from the source observable, it's immediately processed. The mapping function executes, which creates the new inner observable. It then subscribes to that observable, and the GET request is issued, using the emitted string as an ID. When the response is returned, the data emitted from the inner observable is merged into the output stream. Since the inner observables are executed in parallel, they are merged into the output stream in no particular order. If the first retrieve took longer to process, the A1 data could be emitted after A2. More formally, merge map, also known as flat map, is a transformation operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When each item is emitted from the input stream, it's mapped to a new inner observable as specified by a provided function. The function passed to the higher order mapping operator must return an observable, or a structure that Rsjx knows how to create an observable from, like an array. Merge map subscribes to this inner observable. The inner observable emissions are merged to the output stream. Use merge map to process in parallel when order doesn't matter. Consider using merge map if you have a set of IDs and want to use those IDs to retrieve data and order doesn't matter. Let's try it out. In this demo, we try out the merge map higher order mapping operator. Before we start this demo, let's make two quick changes. First, in the product service, let's comment out our tap operator so we can focus on the logging generated by our higher order mapping operators. Back in the supplier service, let's reformat the constructor code to condense the display. Now let's try out the merge map. Let's copy our prior code and change concat map to merge map. Change the stream name, change the tap text, and change the operator. Then add the import for merge map. We'll again subscribe in the constructor. What do you think we'll see in the console? Before we look, note that we still have the concat map executing as well. Viewing the application in the browser, click on Product List. Scrolling up, we see the 3 source observable values from the concat map example, then the 3 source observable values from the merge map example. The first concat map inner observable emits, and its emitted value is logged to the console. Since the merge map executes its inner observables in parallel, we see the emitted values from all its inner observables logged next. Then we see the second, then third concat map inner observables emit their values. Even from our simple example, we can see the benefit of using the parallel processing of merge map over the one-at-a-time concat map if order doesn't matter. Lastly, let's check out switch map. Think of switch map as higher order mapping plus switching. Just like the other higher order mapping operators, switch map transforms each emitted item to a new inner observable as defined by a function we provide. Here we map each emitted item to an observable that emits the item. Switch map is different from other higher order mapping operators in that it unsubscribes and stops the prior inner observable, then switches to the new inner observable. We'll use the same example once again, but this time we pipe each string through the switch map operator. On the marble diagram, the source observable emits 2 strings. When A1 is emitted, the mapping function executes, which creates the new inner observable. It then subscribes to that observable and the GET request is issued. When A2 is emitted, the mapping function executes, which creates a new inner observable. Switch map then switches to that inner observable, unsubscribing from the prior inner observable and subscribing to the new inner observable. In this example, it unsubscribed from the A1 inner observable before A1 had a chance to emit. When the response is returned, the data emitted from the inner observable is merged into the output stream. More formally, switch map is a transformation operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When each item is emitted from the input stream, it's mapped to a new inner observable as specified by a provided function. Again, the function passed to the higher order mapping operator must return an observable, or a structure that Rsjx knows how to create an observable from, like an array. Switch map switches to this inner observable, unsubscribing from the prior inner observable and subscribing to the new inner observable. The inner observable emissions are merged to the output stream. Switch map completes when its outer observable completes. Use switch map to stop any prior observable before switching to the next one. Consider using switch map for operations such as type ahead or autocomplete when you want to restart the search as the user types, or when displaying a list and the user selects item 1, whoops, no, item 2, and we only want to return their last selection. We'll see an example of this a little later in this course. Let's give switch map a try. In this demo, we switch to the switch map higher order mapping operator. As before, our goal is to retrieve the set of suppliers for a particular product. Again, we mock up an observable containing the list of supplier IDs. This time we'll use switch map and see how that works differently. I'll paste the code. First, we add switch map to the import statement. Here we define an observable of IDs. We pipe each ID through a set of operators. Use tap to lock the ID coming in from the source observable. We use switch map to transform our ID value into a new inner observable. But with switch map, each time a new source item is emitted and mapped to a new inner observable, it unsubscribes from the prior inner observable. Let's again add a subscribe to the constructor to try this out. We are now subscribing to all 3 higher order observables. What do you think we'll see in the console this time? Bring up the browser and click on Product List. Scrolling up, first we see all the source observable values emitted for each of the 3 operators. Then the first concat map observable emits, and the result is logged to the console. The merge map executes its inner observables in parallel, so we see all its inner observables emit a result that is logged to the console. We then see 1 switch map inner observable. Because switch map cancels the prior observable as it subscribes to the next one, we only see the result from the last inner observable. Then we see the second and third concat map inner observables emit a result. That's because with concat map, each inner observable must complete before the next one is executed. This example illustrates the key differences between these higher order mapping operators. Looking back at the code, we won't use these observables in our application, but we will use something similar later in this course. For now, you can delete them or keep them for reference. If you plan to keep them, consider commenting out the subscriptions to prevent excess output to the console for later demos. And in the product service, let's not forget to uncomment our products tap operator. Now let's finish up this module with a brief summary and checklist for using the features we've covered. A higher order observable is an observable that emits observables. The observable we start with is the source observable. When working with higher order observables, it's also called the outer observable. A higher order mapping operator, such as merge map, creates the inner observable internally. The function passed to the operator takes in each item emitted from the outer observable and returns the new inner observable, which in this example is the observable returned by the HTTP GET method. So we start with a normal stream. The higher order mapping operator transforms it to a higher order observable, which is the mapping part of merge map, and then flattens it back to a normal stream, which is the merge part of merge map. The result is a stream of items emitted from the inner observables. In this example, a stream of apples. Use higher order mapping operators to map emitted items to a new observable, automatically subscribe to and unsubscribe from that observable, and flatten and emit the results to the output stream. The function passed to a higher order mapping operator takes in an item and returns an observable. If you have nested subscribes in your code, consider trying out a higher order mapping operator instead. The 3 higher order mapping operators we discussed in this module are concat map, which waits for each inner observable to complete before processing the next one, merge map, which processes inner observables in parallel, and switch map, which unsubscribes from the prior inner observable and switches to the new one. We're now ready to put all the pieces together, combining all the streams for a view. A view may need multiple streams to collect all its needed data and handle all its operations. Welcome back to Rsjx and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and in this module we combine all the streams for a view for the ultimate reactive component. Often our users want data from multiple sources in a single view. The product detail view displays a product and the list of suppliers for that product. That makes it easier for the user to order more products when inventory is low. There may be other information displayed on the page that changes when an action occurs. In this example, the header changes when a product is selected. If we define streams for all the displayed data and actions required for a template and combine those streams, we can use a single async pipe to bind our template to the one resulting stream. In this module, we examine two approaches for working with related data, such as the suppliers for a product. We walk through how to create streams for other bound content in our template, such as the header. Lastly, we combine all the streams for a view and simplify the binding in our template. Let's get started. Displaying a view often involves more than just one data stream. There may be related data included in the display. The users want customers with their overdue invoices, or users with their recent change requests, or a product with its suppliers. One technique for working with related data is to handle it in the back end. If the back end server allows it, we issue a single request for the specific related data. For example, all suppliers for a specific product. But the back end may be legacy or third party, so that's not always an option. There are several approaches for getting related data for a view in our Angular application. We'll cover two: Get It All and Just in Time. As its name implies, the Get It All approach gets all data from the related dataset, and then finds the related items within that dataset as needed for display. For example, the user selects a product named Cart. We get all of the suppliers, or use the cache list of suppliers, then combine the product stream and supplier stream to find the suppliers for the selected product. The output stream contains the related data, in this case the suppliers for the selected product. We used a similar approach when looking up the product category. We retrieved all product categories and then found the category we wanted in that list. Use this technique if the related dataset is a reasonable size and doesn't change often, so you can cache it. Alternatively, we retrieve just the related items we need when we need them. Again, the user selects a product named Cart. We use the set of supplier IDs from the product, issue a GET request for each supplier ID, and merge them. The output stream contains the suppliers for the selected product, which we can collect into an array. This leverages the higher order mapping techniques we covered in the prior module. Use this approach if the related dataset is large or if it changes too frequently to cache. Let's try each of these techniques. In this demo, we'll use the Get It All approach to get the suppliers for a selected product. The Get It All approach requires two steps: get all data from the related dataset, then find the related items for display in that dataset. We are back in VS Code with the APM folder open, looking at the supplier service. Our first step is to get all the data from the related dataset. In our example, that's suppliers. In the supplier service, we get all the suppliers using the same technique we use to retrieve products and product categories. I'll paste the code and add the needed imports. We call HTTP GET to issue the GET request, and the HTTP client service maps the response to a supplier array. We pipe the emitted array through tap for debugging purposes, use share replay with a buffer size of 1 to cache the data, and catch any errors. Now that we have all the data from the related dataset, let's find the related items for display from that dataset. Our first question is where? Where do we put the code that finds the suppliers for a particular product? We are working with both products and suppliers, so does it go in the product service or the supplier service? A good general rule is to look at what the data is for. This is the list of suppliers for a particular product. So let's put it in the product service. Our goal is to get the associated suppliers for a product each time the user selects a product to display its detail. I'll paste the code. This code uses techniques we've already covered. Use Combine Latest to combine the selected product stream with the data stream of all suppliers. Recall that the selected product stream already combines the products with categories and the product selected action stream, so it emits each time the user selects a product. Pipe the result through a set of operators. Use array destructuring to assign a variable to the emission from each input stream. Then we use the suppliers array and filter to only those suppliers that are in the product's array of supplier IDs. Hovering over the selected product suppliers property, we see it's an observable that emits an array of suppliers. Let's use this stream in the product detail component. Create a local property, assign it to our selected product supplier stream, and add error handling. Notice how similar this code is to the product $observable code. In the product detail template, we bind to this stream. Here, where we display the suppliers, we change the ngIf to use the async pipe. I already have the UI elements in place to display the suppliers. Let's check it out in the browser. Select the product list alternate UI. We see the list of products. Click a product and we see the product detail with the related suppliers for that product. Yay! Click a different product and we see the view update with the selected product information, including that product's suppliers. Now try this. Refresh. Select a product again and watch the delay in displaying the suppliers the first time we select a product. But then when we pick another product, the display is almost instantaneous. That's because we're getting all the supplier data the first time, caching it, and reusing that same data each subsequent time. Now let's try displaying the related data using the just-in-time approach. When retrieving related data for a stream, such as a customer's invoices or a product's suppliers, we can get all the data from the related dataset and filter that dataset using the Get It All approach. Or we can get the data we need just when we need it. We implemented the Get It All approach in the last clip. Let's look at the just-in-time approach. Our product shape includes an array of supplier IDs. When the user selects a product, we'll use that array to retrieve the specific suppliers for that product. When we have an array of data and we want to issue one or more HTTP requests, creating inner observables, we use a higher-order mapping operator. Higher-order mapping operators, such as merge map, transform each emitted item into an observable and automatically subscribe to and unsubscribe from that observable. In our earlier code example, we used merge map to map each supplier ID in the source stream into an observable returned by HTTP GET, and then merge the results. But here we have a hard-coded list of IDs. In our application, those IDs are a property of the product. The code we need then is similar, but a bit more complex. Let's walk through it with a simplified marble diagram. We start with the selected product $stream, which emits the currently selected product. This stream is active and will re-emit and re-execute this pipeline each time the user selects a product. We need the supplier IDs from that selected product. The first merge map transforms the selected product into an observable. The FromCreation function creates an observable from the product's array of supplier IDs, emits each ID, and completes. We pipe each emitted supplier ID into another merge map. The map part of merge map transforms each supplier ID into an observable returned from HTTP GET. Each inner observable emits one response, which is the supplier. The merge part of merge map merges the results into a single stream. This is similar to the technique we used in the prior module. But our UI doesn't want a stream of individual suppliers. It's expecting an array of suppliers, so it can use the ng4 directive to iterate them for display. So lastly, we use the toArray operator to collect all of the emissions, and when its input stream completes, it emits all of those emissions as a single array. One important note about this code: toArray only emits when its input stream completes. It can't produce an array of emissions until it has all of those emissions. But our source stream, selected product dollar, does not complete. It continues to emit each time the user selects a new product. How do we complete a stream within a stream that does not complete? Notice the inner observable. This creates a separate context. The fromCreation function creates an observable stream that emits its array elements and completes. Since the toArray is within this context, the toArray completes. Use this inner observable technique to define a stream that completes, or for encapsulating operations that could generate an error when you don't want the error to stop the outer observable. This is the code required to get related data just in time if the parent data provides the IDs to the related data. Let's give it a try. In this demo, we'll use the just-in-time approach to get the suppliers for a selected product. In the product service, let's start by commenting out the get-it-all approach and try the just-in-time approach, getting just the suppliers we need for the selected product. I'll paste the code from the slide and add the needed imports. We've already talked through this code. It starts with the selected product, creates inner observables from the array of supplier IDs for the product, issues an HTTP GET request for each supplier ID, creating inner observables, merges the result into a stream of individual suppliers, and uses toArray to collect the emissions and emit them as a single array. Hovering over selected product suppliers dollar, we end up with an observable that emits an array of suppliers. But let's make one more change before we try it out. Let's add a filter operator at the beginning of the pipeline to skip the process if the selected product is undefined or null. This happens when the page is first displayed, before the user has selected a product. We can use this shortcut syntax. This takes advantage of the fact that Boolean is a function that returns true when an item is true, and false when the item is false, undefined, or null. Bring up the browser, select Product List Alternate UI, pick a product, and it displays the product suppliers. It works. Pick another product and notice the delay before the product suppliers are displayed. That's because we are issuing multiple HTTP requests, and the toArray waits for all inner observables to finish before emitting the array. Use this technique anytime you need to use IDs from one stream to retrieve related data, just when it's needed. Before we move on, let's look at one more thing. Let's add a tab to our selected product suppliers dollar pipeline. We'll insert it after the toArray to see the final result. Checking it out in the browser, open the developer tools and select a product. We see the suppliers listed in the console shortly after the product is selected. Clear the console. Now let's pick several products in quick succession. I want this one, no, maybe this one. Notice that it retrieves the suppliers for each product, even after we've long since picked another product. This could lead to incorrect results if the retrieve's returned out of sequence. We could be looking at the related data for the wrong product. Going back to the code, let's change the first merge map to a switch map and add the needed import. Switch map switches to retrieving the data for the latest selected product. Note that we don't change the second merge map because we do want to retrieve all of the suppliers for that product. In the browser, clear the console and again pick multiple products in quick succession. Notice that it now only returns the suppliers for the last selected product. That's better. It not only reduces hits to our server, but it ensures we retrieve the suppliers for the correct product. Now that we've walked through both approaches, let's compare them. The get-it-all approach uses our declarative pattern to retrieve all data from a related data set. The just-in-time approach requires a bit more complex code. The get-it-all approach combines the data observable with the related data observable and maps values as needed. The just-in-time approach requires higher-order mapping operators to retrieve the related data for each source value. With the get-it-all approach, there's a delay when first getting the related dataset, but then selecting an item displays the related items instantly because we are filtering data that was already retrieved. We see a delay every time with the just-in-time approach because we retrieve each related item every time. However, the get-it-all approach gets the entire related dataset, all invoices or all suppliers or all posts. This could have a performance impact if there is a lot of data, and seems unnecessary when the user may only look at one or two related items. The just-in-time approach only retrieves the data needed for display. Select the best approach based on the size of your data and the requirements of the application and your users. Next, let's look at ancillary streams we may need in our components. There may be other information displayed in the view that must also react to user actions. For example, when the selected product changes, the header here must also change. We can use streams for these purposes as well. How would you define a stream for this header? We use the product dollar stream, which is the currently selected product, and a simple map to map the product to a string. We use the ternary operator. If the product exists, we map it to a string. Otherwise, we map it to null. That looks easy enough. Let's give it a try. In the product detail component, let's change the hard-coded string into a reactive stream that includes the name of the product. I'll delete this page title property and paste the code, adding the needed imports. Before we try it out, we also need to change the binding in the product detail template. We bind to the observable stream using the async pipe. Checking it out in the browser, click a product, and our header now reflects our selected product. Nice! Looking back at the template, we now have multiple async pipes. Up next, let's see if we can combine them. A view that displays data from multiple sources or reacts to multiple actions requires several streams. We bind to each stream using an async pipe. Our product detail template now has 3 async pipes, one for the currently selected product, one for the product's suppliers, and one for the page title displayed in the header. For a view that assembles or summarizes data or has a lot of interactivity, there could be even more streams and more async pipes. What if we could combine all the streams for our view? With only one stream, we'd only need one async pipe. As a throwback to AngularJS, we'll name it VM$ for ViewModel, as it holds all the data and actions for our view. Let's jump back into a demo and combine all the streams for our view. Looking at the product detail component, we have 3 streams: product dollar, which is the selected product, page title dollar, which is the title for our header, and product suppliers dollar, which is the related set of suppliers for the selected product. How do we combine these streams? If you said combine latest, that's a great answer. I'll paste the code and add the needed imports. We combine all the streams for our component using combine latest. Recall that combine latest emits an array. The latest emitted item from each input stream is an element in that array. In the pipe method, we first use the filter operator to filter out any empty product selection. For the filter, we only bother destructuring the first array element, since that's all we need. And don't forget that destructuring requires square brackets, which must be put within parentheses when used on the left side of an arrow function. We again use the Boolean function technique to check for undefined or null. For the map operator, we destructure the entire array, defining a variable for each array element. Then we define an object literal with a property for each array element. Mapping the array to an object makes the result easier to consume in the template. Hovering over the VM$ property, we see that it provides an object with properties for the last emitted item from each of our streams. I'll move the template to the side. In the product detail template, we now change the first async pipe to VM$ and the as clause to VM. We then use the VM variable to access each property from the object literal. For the title, we remove the async pipe and access the page title using VM.PageTitle. Each reference to product now becomes VM product. For the list of suppliers, we remove the async pipe and reference VM.ProductSuppliers. We now only have one async pipe. That makes our template code a bit easier to work with. Bring up the browser, select a product, and it works. Feel free to combine the streams for the other views in the application. You can find the completed code with these changes in the APM-Final folder of the GitHub repository for this course. Let's finish up this module with a brief summary and checklist for using the features we've covered. There are several ways to collect related data for our views. We covered two in detail. GetItAll gets all data from the related dataset and filters that dataset to find the related data. Just-in-time gets just the related data as it's needed. The GetItAll technique involves merging the stream that reacts to the selection with the data stream providing the related dataset, then filtering the dataset to the rows related to the selected item. The just-in-time technique involves pulling the IDs from the selected item, using switchMap to transform those IDs to an observable, and switching to a new observable if the selected product changes. Then using mergeMap to retrieve the related item for each ID using HTTP GET. Lastly, using toArray to collect the emitted items into an array. To simplify our template and bind to only one stream, we combine all the streams for a view and map the returned array of emitted values to an object literal for easy binding. Only one short module left. As you have seen throughout this course, with Rsjx we can build more reactive and declarative applications. Welcome back to Rsjx and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and the final words in this course include a brief recap, along with key points, tips, and common issues. We explore a few more terms and links to additional information. Let's get started. When we start with Angular, we learn how to use Rsjx to manage simple data coming into our application. Throughout this course, we examined how to combine data from multiple data sources and handle user interactions. We learned better patterns for managing state, multiple datasets, and subscriptions. Our goals for this course were to add clarity in understanding Rsjx terms and syntax. We covered many of the common Rsjx terms, including observer, observable, subscription, higher order observable, and inner and outer observables. We also examined many of the key Rsjx operators. We explored more declarative and reactive Rsjx patterns, Now the only procedural methods in our application handle template events or provide utility functions, such as exception handling. All of our Rsjx operators and creation functions are specified on the observable variable declaration. We leveraged our new patterns to better manage our data and application state. We used combination operators and merged data from multiple sources to prepare data for display and react to user interactions and state changes. When a user performs an action, our streams automatically respond and update accordingly. Our current code has no real subscriptions, and no subscribing means no unsubscribing, so we don't have to manage our subscriptions. The async pipe handles that for us. By combining all of the streams for a view, we only need one async pipe for all our template data. We do have a second async pipe in the template for our error handling because we don't want to combine our error handling stream with our data streams. We improved our UI performance by implementing Angular's on-push change detection and using the share replay operator for data caching. Next up, key points, tips, and common issues. With new techniques come new issues. Let's look at some key points, tips, and resolutions to common issues you may face when working with observables. Let's start with Rsjx operators. Import each operator from Rsjx/operators. Specify the operators within the observables pipe method. When working with creation functions, import each creation function from Rsjx. Some creation functions, such as combine_latest, have an operator with the same name as the creation function. Many of these matching operators are now deprecated. Be careful when you use your editor's automatic import feature. It may import from Rsjx operators instead of Rsjx. You'll then see an error when trying to use the pipe method with the creation function. If you see this error, check the import statement and ensure you are importing the creation function from Rsjx and not the operator with the same name from Rsjx/operators. To aid in debugging observable issues, use the tap operator to display data about the stream. Insert it anywhere in your pipeline. Use your editor features and hover over an observable to verify it's returning the expected type. In this example, hovering over the product's $observable displays observable of product array, which is an observable that emits an array of products. We often use observables when retrieving data using HTTP. Keep in mind that a data stream returned from HTTP GET emits one item, the response. After emitting the response, the data stream completes. It won't emit any more items. When retrieving a set of data, the response is often an array. To transform the individual elements in the array, first map the emitted array. Then use the arrays map method to map each element in the array. Lastly, transform each array element, creating a new element with the desired shape and type. When working with an action stream, note that an action stream only emits an action if it's active. If the action stream is stopped, it won't emit any more actions, and the application won't react to that action. An unhandled error in an action stream causes the stream to stop. Catch any errors and replace the errored observable to keep the stream active. Don't replace an errored action observable with empty, as it will complete the action stream. Replace the errored action observable with the default or empty value instead. The combination operators that combine values from multiple streams into an array don't emit until each of the input streams emit at least once. This includes combine_latest, fork join, and with latest from. An action stream created with a subject does not immediately emit. When combining with an action stream, consider using a behavior subject instead. since it emits a default value upon subscription, ensuring the action stream emits at least once. Some creation functions, such as fork join, and some operators, such as toArray, require that the input observables complete before emitting an item to the output stream. Take care when using these functions and operators with action streams, because action streams often don't complete. In this example, selected product dollar is an action stream that emits each time a new product is selected. It does not complete. We define a higher order observable which does complete, and use the toArray operator on that inner observable. If you use functions or operators that require completion and your observable is not emitting items, ensure it isn't waiting for a stream to complete. Now let's look at a few more terms often used when talking about observables. You may hear the terms hot and cold when referring to observables. A cold observable doesn't emit until subscribed to and is normally unicast. An observable returned from an HTTP GET call is an example of a cold observable. We must subscribe, or let an async pipe subscribe for us, before it emits any values. A hot observable emits without subscribers and is normally multicast. Creating a subject or behavior subject defines a hot observable. Using the next method, we emit items to the observable stream, even if there are no subscribers. There's always more to learn, and the Pluralsight library is a great resource. For additional information on state management with Angular, check out Angular Component Communication, which covers several techniques for state management, and Angular NGRX Getting Started, which covers the popular NGRX state management library. For more information on Rsjx, not necessarily within Angular, check out Rsjx Getting Started and Learning Rsjx Operators by Example Playbook, which walks through every Rsjx operator in a reference manual format. And of course, the Rsjx documentation is a great resource for furthering your knowledge of Rsjx. Congratulations! You now know how to leverage Rsjx observable streams to build more reactive and declarative applications. Yay! I'd love to hear about your experiences with Rsjx. Reach out on Twitter. Thanks for listening.